Alright, let's do this. We're gonna be doing a relatively short attempt at this. We're just gonna do a naive approach, which is far simpler than what the crap I was doing before. It's all gone. Only thing we have is what we need. We're gonna be doing a turnaround approach from what we did before. I just want to get this done so I can actually keep up with the days. I'd be annoyed if I wasn't. What I'm going to be doing here is do a top-down approach. First of all, I'm going to do a get bag or get containers as well. So make a quick function. Be bag get bag, which will be a name. And because we have a vector of rules, I want to make this look fairly quick. So what I'm going to be doing is I don't think a bag has lookup 1. I think an array has lookup 1. Looking for complexity here. Doesn't really matter. For bag B in rules, if b dot name equals name, return B. It's just to get the bag we're looking for. Most we're actually going to want is actually get a vector. This of the bag is what we want, but I need the amounts probably later. So what we're gonna do is we're gonna go. So what I do is already discard anything that doesn't have anything in it, so I know I can iterate through it. So we're gonna do for bag B. Let's do bag sub bag in B dot contains. So for every bag, we basically want to find the shiny gold bag. That's what we want. I could save this beforehand, actually. We want to find any that contains. So what we do is we compare this sub bag, if it's gold. So what we're basically doing is we're not starting at the first node, because the rule sets are all reversed. I could build that in reverse, but it doesn't really matter. What I do now is I search through my bags, and I could actually print this. If I just do this, it's fairly quick. So what I do now is I go through light red. I see, hey, it's bright white. Hit it yellow. Yeah, none of them are gold. I ignore it. But then what happens here, I go to bright white, and then I go shiny gold. And then I go through every single one and see if it contains a bright white. And this way, and then what I do is I add it to a set. And then at the end we can count the sets. So it'll be just a set of strings. Answers. Because then basically what I can do is if I get through muted yellow and I go up, I still add light red to it, sure. But it's already gonna be, I can just check if it's in the set already, and if so, just ignore it. I want to watch, but I couldn't motivate to do myself this, and I want to spoil my own solution. Look, if you think we're gonna add to a solution today, good fucking luck, because I already spent 4 hours on this morning on a awful solution that I should have just axed the moment that I saw it went wrong, but I kept adhering to my awful ideas. Anyway, We want to know if the sub bag is gold. We can do this very easily by doing a compare bag. So let's compare color of the sub bag. If this is true, we've hit gold. This can only happen once, so I'm gonna be doing this slightly different. I'm just gonna make a few bag find gold. Picking up CPU was a bad solution. It should have been X like 3 days. I really would like to adhere. Like, I wanna do it. I wanna do CPP because I think it's a useful skill to have. I basically want to do this because now what I can kind of return 0 the moment that I get it. Because I just need to return return true, otherwise return false. Actually, it's already bags. There we go. I like that. Yeah, it's there for a goddamn reason. So if find gold, which will be what is it? B dot contains. So first of all, I want to actually do this here. Should put it up your M. Should put it up as your MS profile. Yeah. I need to actually crop that from the top if I want to do that. There we go. Yeah, just copy this still though. Just comment it out. So the approach we'll be doing is the other way around from before, but it'll allow us to just ignore anything doesn't start with gold. We're still going to need to do a lot of searches. The reason I would like to actually improve that, though, I know there's a few ways, but I'm not going to do it because that's what bit me before. Is I tried to do optimization before we even had a working answer, and I should have just not done that, but I did it anyway. Because I know like a billion ways to speed this up, and the reason why I've been in that mode is because I've been working in an environment where I need to do that, because otherwise my program is going to take half an hour, and I really should have gotten out of that. And people were kind of telling me that, but So we found gold, and then what do we do if we find gold? Great. First thing we do is to the answers. We add the current bag.name, to b.name. So that's our first insertion. And now we have to search up this tree. Hey there, pizza. Yeah, be glad you weren't awake this morning because it was awful. Actually terrible. 4 hours on nothing. So the answer at the end, like count answers.size, is it? Size is going to be our final answer. So if we do it now, we get 2, which makes sense because that's the only ones that have basic bags in them. But now I want to go up this tree. And that is going to be recursive. There's really no better way to do this in recursive, I'm pretty sure. But basically what I want to do is I think I would have been awake for the start, but typically my mornings are filled with meetings. Yeah, it really wasn't a great stream anyway. Okay, it was fine because it was like, the issue was that I didn't have a good way to check for errors. I've been having a lot of errors that I couldn't. Sorry, I didn't have a good way to find errors, so most of the time was spent just like figuring out ways to find errors rather than properly correcting them, and that sucked. Regarding adhering, I can kind of get you, and I want to deepen my Python skills instead of learning completely new. Been filling with some module type, pretty glad with the results. The issue is that for my professional work in the future, Python will be an option, but never super in depth. and if I wanted to do, I've done 2 years in Python, and I would like to think I'm pretty alright at it. So I'd like to learn something new, especially because CPP is a language that I would like to be able to know, because I assume that, for example, in a bit I'll be programming I might be programming microcontrollers for lasers. Like, it's not gonna be exactly like Python material, so it doesn't matter much anyway. Anyway, we want a recursive search on the bag itself. We don't actually care about its content, we just want its name. So this will be string name. The reason why I can do that is because I am using globals, and I don't want to recursive search of just b.name. In programming microcontrollers, and I tell you what is it gonna be in? You usually don't need any high skills for that. Basically, you'll be fine with your current skills. Exactly. But at that point, it's a personal choice, and then my personal choice is I want to try CPP. But as I've mentioned before, if it gets truly untenable, I'll hop back to Python, because I know that you can do it today in C++. It's not that difficult. It's just that my approach was, slamming my head into a wall. It would have been literally faster to just do it by hand. After, like, in hindsight. So what I want to do here is I want to go up the tree, and then if it's goals, we know everything up the tree needs to be added. Can always learn something new. That's exactly what I'm doing right now. Fuck doing this in Excel. I refuse. I'm already good enough in Excel. I don't want to do this as well. Anyway, good old Excel indeed. So what do we want to do? So we have a name of the bag, and we want to find, for every rule we have, if it is in the contains section. That is not very easy, but that's the easiest way to do it. And the good thing then is that I already have what I'm looking for, basically. So for bag be in rules. But are you that good with HLOOKUP? Yes, I've done a crap with that. I posted it a long time ago, but I created a huge file where how do I even explain that properly? You would calculate transfer efficiencies between different proteins on DNA with Excel. And if you don't understand how that works, just imagine 7 or 8 tables. So it's like square matrices of tables that had to be combined into a singular value using HLOOKUP and VLOOKUP and a whole bunch of other crap. And comparisons and other shit. It was, oh god, it was something. Anyway, so for every single rule, which are about 600, we're gonna be checking inside it, because we have to check the right-hand side of every rule, basically, if this bag is in there. Can I find it? It was on my university computer. I don't know. Because I know that I posted it ages ago. I'm just gonna quickly see if I can find it. Nah, because if I can find it quickly, I know where it is. Because it should be in my university box for research methods. Oh, here it is. Oh yeah, there we go. If I knew if I was going to find it easily, I could find it easily. Perseus results Perseus is like 2 megabyte Excel file. Good grief. Well, I want to show you one of my formulas, which I think was about 10 lines long. water, glycerol. No, this was what I was looking for. Oh, this was for this is very different stuff. This is where we're using it for, oh, was it FCS? What was it again? It's like, it's a method where you can measure the concentration of a solution, or sorry, the diffusion constant of a solution with a small laser. And if you don't understand anything, don't worry about it. Because I think it was this one. Since it's the largest, and I'm pretty sure it would be that one. Yes, that's the one. Alright, I'll see if I can find it. Wait, is this filtered result? Oh crap, this is protein crap. This is results from a protein analysis. It's a bit weird. Where would it be? Bioimaging? Is it biophysics? Oh well, it doesn't matter. I don't think I've got it here. Bioimaging. It might be this one. This is the only one I can think of that it could be. But I think I already opened it. Oh, that was copy of SC example calculation. This is not the one that I'm gonna K a pretty table. Yeah. We had to make pretty tables for a report there. And main graph, yeah. Was this it? Cerulean, yeah, this was it, I think. No, this was decay curves. These are intensity arbitrary units. No, this is not it either. This is all from, I know what course this is from. And this is not the course that I'm thinking of. What course was it? It might have been another course, but I think I don't know. See, the thing is, I know that I posted the results to someone somewhere. Which means that I know where it is. Sorry, I know that I have it somewhere, basically. Simon Boxicum, it might be that one. But I don't remember the exact course. No, these are emission spectra measured from a purified protein. Alright, let's just ignore that. I'll see if I can find it later, because it has some really interesting things there. Anyway, recursive search. For every bag, we're going through every container bag, so B dots contains. And we're basically beginning saying, I could also just do find bag. And then I can just do a string. Actually, no, so find bag. The thing is, right now, compare color is always done to the same color, but I can always just make that a string. And just make it string tar. It's easy. And then here I just do find bag. And just have tar here as well. Have you checked Discord program? I've been avoiding it. You can see I've talked in there a bit, but I've been skipping all the solutions and other stuff like that. So here we're going to be searching for name tar. But here we'll be searching for, I mean, you're complaining about not find gold because it's find bag. Not find gold, because that's true. Because then what I can do is for bag and rules, I can do find bag of b dot contains, comma name. And so, hey, if this is true, yeah, so I have no idea what solutions you guys use. Hey, it's kind of the same like this. It's kind of the same like this. So that works for this example. I know that there's multiple solutions possible. I know that as soon as you step to libraries, you can do a ton of crap. Because so many libraries support creating trees from data, basically. Because since you have unique combinations of adjectives and nouns, or colors and adjectives, I mean, you just combine them into a unique identifier, And there you have your node ID, and then you start connecting them with those rules. And then you can add values to those paths by doing like a number. And then if you want to like, I don't know, I assume that the final question will be like how many total bags will have the largest path, something like that. You can just like do it all. So I've stored that value here just for the bragging memory. What a guy. If it's a one-liner, then that's pretty impressive. So we got right answer there. So we got the correct answer. So what I can do is I can quickly test it on my puzzle inputs. Just for the bagging memer. What a guy. Not even bragging, but bagging. So I would like to actually do an int I equals, so just to do a counter so I know where we're at. It's gotta be 113. It's just no, it can't be 113. Because we know that number also arrived due to our whatchamacallit. What was it? Our incorrect. Okay, first of all, stop print bag, and I also actually want to use Marvin's input. So I know if it's correct, because I don't really care about entering incorrect things. So the answer we're looking for with Marvin is, if I go to my original input, was 192. But as you can see, it's slow. And I knew that. I knew it would be slow. And the reason why it's slow is because it has to do everything recursively. And I actually, oh yeah, I can very quickly do that. It's very simple. Where I only do a recursive search if answers dot find b dot name does not equal answers dot end. There we go. So this is extremely quickly. Just a very simple, don't bother doing this if you already know we have seen it before. Because we don't care about numbers here. Why does it stop at 172? Time to see if Nitro can. I don't know what you're talking about. There we go. 192. That looks slightly more correct. Wait, 192. That is correct. See, I knew it was a fairly simple way to do this. Jesus Christ. But why is it? I have a feeling 192 is a very long chain of just garbage. Oh, we got the right answer. And it took literally 20 minutes to rebuild our solution. Fucking 20 minutes. Instead I spent 4 hours on this garbage. So look at that, 2 megabytes of memory. What a memory, that's what I know. See, this is why I hate myself, because it would have been so easy to do this morning. There we go. Considering your shiny gold bag, it has other bags, yeah. A single shiny gold bag must contain 1 dark olive bag. Wait, what? Bag count 0 other bag, contain 0 other bag. Say the other bag 3, yes. Wait, what? Did it have like shiny gold? Yeah, shiny gold bag contains that. Contains 7 other bags, so must contain everything there. And the 11 bags within each one of those. Yeah. Small chance going deeper levels than this, be sure to count all of them. Okay. Ha, that's where you got your example from. Oh god, how do I do this properly? So it's kind of what I thought before, it's just multiplication. So you actually go down every single tree and add the amount together. But now instead of doing like a top down, we do a bottom up search. So first of all, we need to stop doing this. Actually, we need to always use it because we need to know. We should probably do that though. Anyway, so this is part 1, basically, because part 2 is completely different, basically. Find bag. Yeah, this actually just finds if the bag is there. It doesn't even return the bag, because that's literally all it needs to know. So we actually have the amounts that every single bag is in the other ones here in the vector of an int, which is just indexing basically. So I can't use normal looping because I don't think there's enumerating. No, I see your answer there, Hamster, on Discord. No, just to tell the bot that no, that's not me, despite having the same name and profile picture. So that's part 1 done. So because I know that part 2 is going to be... this is slow as hell, by the way. I'm just curious why exactly it's so slow. So I can just kind of keep it here and just do it later. So for part 2. So first what we want to do is we want to find the gold bag, since we need to know what does it contain. So I can just actually get like a... I can actually get just a gold bag one here. Because I can just do like if though I'm not sure that we'll work with reference. Let's just not do that. It's just a single search. It's super fast. But anyway, there we go. So for bag, actually I could even do that in here. So, but no, let's not bother. I could unify these if I wanted to, but I don't care. If b.name equals name tar gold bag. This bag. There we go. So now we have our gold bag. Sorry, it's B. So what I need to do now is actually go down this thing. What is in there? And so for every single level, every depth, we return a score. And this is kind of what I did before, and that utterly failed. Let me actually put in you. So what do we actually have here? So shiny gold, 2 dark red, 2 dark orange, orange back into 2 dark yellow, 2 dark green, dark blue, dark violet. Yeah, no other bags. Yeah, so that works. Actually, I can always just add this in here. There we go. So now I want to go basically for bag B in gold bag dot contains. Yeah, well, I wonder where I've seen those numbers before. Anyway, so now what I actually want to do is I need to actually do a numeration here, basically. So that kind of sucks, but it is what it is. Aren't you parsing numbers out? No, I'm not. They're just not shown there. They're saved in the amounts. You'll see it. You'll see it right here. I is less than gold bag dot contains dot size I plus plus. And then we'll do bag b equals bag dot contains I. And here we'll do int amount equals gold bag dot amounts I. And here I can actually do print bag, and then I can actually count the number there. It'll give me nothing in the end though, but hey. The reason why it will give me nothing what it contains because I'm not getting the proper reference here. Dark red 2. That contains 2 dark reds. Which is what I'm looking for. So one way I could speed this up immensely is by actually having proper pointers around. I don't really care for that. I just want it to work. I don't think this is a day I'm going to be optimizing at all. But we'll take a look at other solutions. Let's see. So I kind of do the same thing we did before. I just go up. I'm just thinking what's the best way. I could actually add in a depth number and just figure that out later. We're really stupid, but it could work. Have you seen D3 factorial? There's a fucking factorial solution for day 3? That's amazing. I'll take a look at the separated after this. There's a thing I think I'll be able to solve this today. So now I kind of do what I did before, but instead of adding into a set, I have a map, and that map will be results. Will be a map of a number and of an int and an int, basically. And the int will be the depth, and the other int will be the number of bags at that depth. So this will be no bags, depth. And the depth is like the multiplication you need. And the reason... Oh god, no, because you need some other crap. Because you need to do multiplication of multiplication, so I need to actually know some kind of recursion, which is, I know within it, so that's kind of fine. Because I know that, hey, if below me there are 31 bags, and my own value is 7, then return 7 times that value. So that'll work actually fine. So that'll be kind of like so we're gonna make another recursive function, which will be int day, well, part 2. I just call it part 2. I don't care anymore. Which will be a string of name. It'll return 0 for now. And then for all of this, what we can do is we can do let's actually part 2. Plus equals amount, which will actually just do this, times part 2 as a so is that a function actually? Yeah. It'll complain about that otherwise. Part 2 search of b.name. And then we just count part 2. There we go. In theory, I could actually just kind of ignore this and do this for gold bag. Yeah, I could actually just do part 2 search. I could just literally do part 2 search tar name.tar. Literally what I could do. Not very difficult. I could kind of ignore all this. Because we kind of need to duplicate this anyway, so so this will be an int temp that I actually need to have here in between, which will be temp return temp. So let me see. First we need to find the bag. So we just search for all the rules until we get the bag that is our name, which will be cur bag, I guess, but that'll be a, I don't need that, so I'll need a bag cur bag here. Just to make sure, cur bag, so we know I have the right one. Wonderful. So what do we do then is, I want to actually get a temp, so we can actually do some kind of recursive search here. So let's see, what do we do? For every single bag, we find the bag, which is just so we can actually see what is in there. What we then do is for every single iteration of stuff that is in there, we turn this, and then if temp equals that. So one thing we need to watch out for is zeros. So we know that if the last bag is empty, it still has to like kind of count itself. Well, sorry, that's counted by you, but like, so it should count itself plus whatever temp is, right? Because it would, yeah, because otherwise you would get 0. Because in the current example, we got 127, which is not the right answer because it also counts the shiny gold bag at the end. So yeah, first one is 2, 6, 14, 30, 62, 1, 126. I actually want to use the original example because it actually kind of tells you some more, and it'll be another example we can use. So 32? Huh. Hey Hamster, do you have your answer for part 2? Yeah, exactly. I want to use your input. Which I think was the 41559. Thank you. Hamster was the second one I tried. Just this one. Yeah, it'll give me one for every single line it finds. So I'll just have to see how long this takes. It's reading the file. Sorry, what the fuck? Why is this working? Why do I not have to tear my hair out for literal hours? Oh, maybe because I was actually competent for once. It took me fucking literally 40 minutes. Wait, no, that's a bit weird. It's way lower than it probably should be. No, something's wrong. I don't trust that. I don't it's wrong. It has to be. How the fuck is that right? Kill me. All that's hours of work, and it worked with like this super simple solution. Oh my god. It's also even like relatively quick. The whole thing probably takes multiple seconds because it's super inefficient, but it's just... There were some rules that took ages. I'm not sure why, because in theory it should be fairly quick, but hey, it works. Let's commit this and then go commit suicide. AOC 2020 commits. My solution, I'll say, let me just commit my own. And then take a look at what other people did. I'm happy it works. The stupid thing is that my original solution is like, it's in concept it's the same. You just do it the other way around. But it just, I wish at the time, it's really fun to do. If I had just decided to go with this morning, we would have, okay, it would have taken a bit longer because we would have had to redo the recheck, but it might have taken 1.5 hours. This is Hamster's solution. Count 3? Let's see, bag count 2, shiny gold. Background to a back.index. So yeah, how do you parse your stuff? So one thing I know, I do it while working. I would do that too. I mean, technically I am. Mm. So um so one thing that is a lot more difficult in C++, I know that there's actually kind of annoying ways to do like fast lookups, because I know that I could add that in. I know I could use a like ancestors. Yeah, you're using graphs. Exactly what I thought a smart person would use. Got too much work to do and not doing this right now, so that's relevant. Learning them, brushing up on Azure, which has been my focus for a while. The fuck is wrong with you, Aftish? Kamada Kawaii layout? Bags, subbag. I mean, I have something of that, I think. Let me see. Extra logging ad. I have this is for Kaiserreich, something I wrote a long time ago. And it should have oh, did I remove that like a smart person? Oh man, it used to have like IDSSSSS. Yeah, I actually removed that, man. I used to have like five layers of IDSSSSSS, but hey, so I know. Bag, sub bag, bag, sub bag, sub bag. Yeah, that's not confusing at all. Also, it's still Weebery. Anyway, but what kind of using adjacency matrix? So I saw you mentioning that before, Hamster. Could you like in a few lines explain how it works, roughly speaking? Because oh, I think I know what you're doing. So you're saying that to go from so from sorry, it's a graph. Yeah, to go from A to B, take this value. So to go from A to B, use this value. That makes sense. So I can very quickly check to see if there's adjacency by just checking it's an O1 lookup inside the adjacency. That's pretty smart. So that would be one way I could speed up my answer, for example, instead of searching through it. But yeah, that's pretty smart. Just basically a simplified graph. And then let's see, back count 2. So I use recursiveness as well. Count 0. If adjacency makes over 1, you flag it. Why do you flag? Oh yeah, this is what I had. So flag is 0, count is 1. Wait, why do you do if flag is 0, count equals 1? Is it because it's like the bottom of... But wait, you're already using the adjacency matrix value here. How would that work? Because part 1 is purely about how many would be able to contain a shiny gold bag. There are no bags inside this one. Yeah, exactly. But why do you make count as 1? Oh, wait, no, you're... Back count 2 minus... Yeah, you're right, because you're only putting on 1 value instead of 2. So what's the difference here? Count flag for chain range... Oh, it's a +1 that's different. Back count 2, J +1. What? Yeah, but no, I do that as well. That's literally this. So you count itself as well. And here you don't count itself. So you basically see what contains it. That's a really... See my fix. Yeah, but this is exactly what I did for part 2, basically. Like I do like, oh, name -1. Like we're doing very much the same here for part 2, except that your indexing, your searching is way faster. because I have to do this crap. And this for bag in rules, that's super duper slow. But I've seen some fairly contradictory things about how to do O1 lookup in CPP. As one of the things I would like to get a little bit better at, to know fairly fast what would be the correct lookup method, the correct storage method. So far I've heard do vectors, but that's nice for index lookup, not for value lookup. Anyway, that's done. Anyway, let's see what other people have. So After's made some nice graphs. Can't help but show those here. So this is basically what I'm, this is a graph. It's literally what it is and what you should be basically constructing yourself. So that's pretty neat. This is the Kamada Kawaii layout. But what is the point? Springs between nodes. Springs? Oh, so the distance is... what? So the distance is related to the value. Why would you do that? Here we go. And this is what is also in CPP. So this is what StimArt did. Class bag. So I would like to start using classes some more because you can add functions and those are pretty good because you already have inherent references to the thing itself. So this, hey, just add to the bag possible containers. Not sure. So how does he do his lookup? Bag is container color. Goddamn Java-like crap. Is this only part? Is this part 1 and part 2? Let's see. While that's for every line, and then you bag.find. It's part 2. Yeah, okay, that's good to know. Unprocessed. Part 1 is one comment back. Well, I mostly care about. Nice. I guess this is all of them. Unprocessed with all the nodes. Looks beautiful. Thanks, Aftish. Wait, how do you define .find? I looked it up. Sass can have rejected it via Perl. To kill myself, I try understanding. Rejects is not very difficult. This is just 2 words, and this is a digit and 2 words. It's basically the same as I did, just with the optional digit, optional space. But how do you do how does that find work? Am I just being stupid? Because bags is, what is bags? Bags is a map. .find lookup color. Yeah, that's basically what I should be doing. Because bag to bag, so insert container color bag. Ah, okay, so you give the color in a separate thing for easy lookup. Yeah, that's kind of what I'm doing, just, more poorly. And then you basically calculate part 1 and part 2 at the same time, sort of. You do second, which is, wait, bags.find. Second is the bag itself, possible container, bags. So for possible container, the possible bag. Yeah, so this is the reference thing that I should have been doing. But how do you do that properly? Yeah, you do define. Yeah, so this is basically what I should have been doing and what I've mentioned earlier as well. And this is the way you would do that. I'd like to avoid using .first and .second, having come a way to do it. Is there even a way to get around that when you have a map? I can't imagine you can get around that. Because you need some way to index into the first or the second aspect of it. It does seem very clunky. Like, isn't there a way to do like an variable-based indexing? But it's like, it's pointers, right? If you unpack the pair, but it's still clunky, ugh. Yeah, no, I agree. That's why I really like the Python One of the good things about Python is it just works. So including that kind of indexing into things, because you can index into a tuple very easily. Anyway, this is kind of what I would have liked to do, and this would probably be the biggest speed up in my code, is basically replace this with that. So instead of having a name, have a reference. Or sorry, actually, no, just have like a map. Literally just do the map. Which, is that difficult to do? No, because I already have a vector of rules. So I would just kind of do, I think not being done before. Yes, it would have been. Let's see if I can actually fairly quickly implement that. A lot of things will go different. So what I need to do now, yeah, because iterators are, yeah, backslash find a second. So what I need to do now is basically replace it with that. So first, let's go to the first section, which is here. Push back, cur bag, and we'll do pair, string bag, right? That's not working. Don't remember pushback. Oh yeah, because it's insert. It's insert. And then we can't do for bag B in rules. So let's first fix something. So this is the dot find. So basically we want to do cur bag equals rules dot find name second. So this is literally kind of what he did. So this replaces that search. And the same would be doing here. However, the frustrating thing is you're kind of assuming it always has something in there. So what I'm basically doing is bag B. And then we don't even do find bag. Oh wait, find bag, what does it do? It takes a vector of bags. This is a little bit different, because now we're actually looking for the sub bags. The thing is, Simar, I kind of assumed it might have like screwed with that. Vector of bags, exactly. So slightly different. What I'm doing here is so for being rules, if find bag. So find bag actually looks through what is a sub container. So I actually don't think I could even do that here. Because what I'm doing here is actually checking the sub containers, which kind of sucks. Which is a bit slow, yeah. Because this would actually be this will be pair and string comma bag p. There we go. So this is not really faster, but it'll make part 2 a lot faster. Kind of do the same here. So I'm pretty sure that there is a better way to do this. But in theory, it should speed it up. Yeah, so get bag is literally, that is literally this. So that one is fairly simple. But I don't think I use get bag anywhere. But yeah, if find bag contains name, tar. So this one we actually don't need to. No, because I'm actually looking through the container. That's the kind of the issue there. So if I wanted to make this faster, I would have had to flip my rule set on its head, which actually would have been a pretty fairly simple thing to do. And I just don't know why it hangs on some of these. It'll still take, like, easy. I want to see if the answer is correct. If so, I'll run it in release mode, because that should be a lot faster. And then we're going to take a look at the subreddit, because I don't think I want to go through. Yeah, it seems like it's doing all the answers correctly. 229? That doesn't sound correct. 229 is correct. Right. So what I'm going to do is I'm going to remove this. Just make sure we don't get all this garbage. And then we do it in release mode. Take a lot of shit. It might take like 10 seconds, I think. Release mode is usually a factor of 10 faster. Never mind, it's literally instant. Okay, I didn't expect it to be that fast. I might need... Okay, give me a second. I'm going to add some timing because that feels weird. How is it so much slower? Like, that is ridiculous how much slower it is. I think I had it on day 1 quite a bit, yeah. Timing is not very difficult. It's just literally include chrono and then do kind of this crap. How is it this fast? I genuinely did not expect that to... Actually, kind of can do this. We're not gonna do multiple iterations here. Just want to do one. Good crivens, that is fast. Start and then part 2. Still assume that Half-Stimar solution is faster. Very slow. Part 1 takes literally 200,000 microseconds. So it's about 0.2 seconds, but still very slow. There's no reason for this to take longer than maybe a millisecond. That was because I wasn't pressing space. There we go. Yeah. Alright, there we go. Let's go to the subreddits. I'm very happy I just kind of fixed that at all. Just that I solved that. So where is the Victoria? Here we go. Let's see. Base encode. Show me that graph. What graph? What graph? Oh, this one. Yeah. But this is all the contents of one shiny bag, like in numbers as well. This one. Higher. Ah, yes. This one, right? Alright. Yeah, so what I assume... Let me actually grab the proper post. What I assume this one does, it kind of does what you do, but have more... Hey, that looks very familiar to yours. Yeah. I really dislike how you can't easily zoom in from there, but I can do it here. So yeah, what I assume this does is kind of the same as you, but the distances between things aren't the same. It kind of has like tree trunks. So this is probably just a pretty visualizer where the distance between things doesn't mean anything. In fact, this is pretty worthless because it just is nice. Like, something like this is actually better because it shows you interconnection between parts and some connections between sections. But the thing is, this kind of data set is so interconnected, it's very difficult to show it properly. They kind of do. What is the value of a connection here? It's just if there is one, right? They're virtually the same. What do you mean? I mean, kind of, yes. But here, amount of connect. Yeah, so the thing is, here it's very difficult to see what is actually... circle and just in a circle. Yeah, but I think it lends itself better to this type of visualization. But I am not going to take much look at that. I'm going to take here. So TLDR GIF. Wait, what was day 3 again? Trunk 1 is... Yeah, I know it's condensed together, but I don't think it actually adds much. That's just me. Oh, it's the forest one. There we go. Yeah, it's the forest one. So he just moves there, and he moves the pixel, and it's red if he hits a tree. That's very neat. Plug X and Y coordinates. Slope, yeah. So the position is very simple because it's literally just a clock, X, Y, and a slope, and you add them together every tick. Yeah, input data in parallel. God, I would have to read all of this to kind of get an idea. I think I'd like to think that I can understand this, but... So where is this proper input parsing? Let me see. Bit shifting end array, sliding 15-bit window. Input data in parallel lookup, that's here. I guess it's... yeah, I see. So it's a huge, long thing where it just kind of gives the value of, is there a tree here on this, like, 15-pixel wide thingy? Or was it 15? It's like 30, I think. I know a lot of data in Factorio is done with bitwise and between bits, so basically have one comparator having a bit. I signals a single line of the day inputs. Convert into a bit mask by the Python script linked above. One important note is to reverse the bit mask. It was done to make bit shifting easier to reason about, but it wasn't necessary. The arithmetic combinators take Y and get plus minus 7 lines as the output value is copper. So this is just a, bit, it's one line of the input as, whatever number bit masked. And this just basically spreads it out. That's actually pretty neat. And this kind of reverses that so you can put it into the pixel assignment array stuff. That's kind of neat. It's just, I mean, Victoria is just a whole lot of stuff. Just a whole lot of, because you have comparators and stuff, it's very easy to do things. Anyway, 30 minutes, just, I don't want to, it took me way too much time. Just knowing that I could have done it in about 20 just hurts me. Jesus fuck, that is little code. So they use a default dict for line and lines, color rematch, inner color. Is rejects twice. ct.nc decoded int. Part 1 is contained in, yeah. It's very neat ways. The thing is, in the end, I came up with the same thing, but it just kind of hurts that it took me this long. Because, like, this code is extremely simple. Part 1 is, like, the actual, like, Recursive search is super duper simple. Part 2, super duper simple. To be honest, not for all the same. Yeah, exactly. There are no other way to do it. Yeah, because well, it depends on how you think about it, because you constructed a graph in one of your, using like a proper graphing library, I guess. But it is true that every other version is just a simplified graph. It's like, okay, for my solution, I just keep track of singular line connections, basically. And the slow part is that I have to check where every line connection is, or the right one I'm looking for. Whereas with yours and with StimRs, for example, there's proper references in there, which make doing that very quickly. So for your solution, you're like, if you have a building kit of Lego, your set is already built, and if you want to find connections, you can just look at the build set. And for me, I have to like look in the instructions all the time. So yeah, slower, but ultimately the same thing. Wait, Vim keystrokes. Oh, this guy again, he still managed. Yeah, I mean, in my first take, exactly. It's like, dicts are just like singular lines, exactly the same. Yeah, what I mentioned. It's just very, it's like very simplified approach. It's like, if, say you were to build something from scratch, this is where you'd start. And the next step up would be StimR solution, where you're keeping references, like you organize them better, so it's way faster to do those lookups. And one higher might be you don't even do those lookups, you keep proper references with pointers, for example, instead of, well, references. Anyway, Vim is just a mess here. It's just kind of chaotic, because you're kind of solution searching brute forcey way. Wait, you did one line? Jesus Christ. Return any DST or FD for D and XC, where X is a dict and FD is yourself. Good grief. But wait, is it off? Yeah, for D and XC. Jesus Christ. Again, recursive searches. It's again literally the same thing we did, just in one line. It's exactly, you were right after. It's basically network X, a huge dictionary, goes in both ways, uses fancy methods. Exactly. Like, that's what I meant. Like, deep down, it's all dictionaries. They just add on features that make it better for graphing. Because I know that, for example, in was it last year or so, where you had this huge network with like 5 different types of nodes, and like it mattered from which node type you came. Because like if you want to go from like a rock to water, you have to unequip your pickaxe and equip your flippers, for example, which will basically add a cost between transversions. And those network X things are amazing for that, because they have implementations. I finished that, but it was a mess. Like, for those kind of things, it's great because you're adding on all these conditions, and they have built-in methods for that, which you could code yourself. But you know why? Maybe I should try that. It's a very interesting challenge, because you're basically implementing, like, it's like that was literally a pathfinding algorithm. It's like costs between traversing nodes. The other asteroids thing was a gazillion of. I solved that one. I'm pretty sure I brute forced it. What day was that? I could take a look at my code, but I don't remember what it is, because I didn't stream anything last year. Anything C. Nice 7 there, kid. Hey, that sounds familiar. Oh, that's kind of sad. Resubmitting your same off by 1 error. Yeah, Network X. Someone else used it. (2018, 23, and 22). Oh, I think I only... Wait, was it 2018? Ah, fuck. I don't know where I have that code. Because I have 2019 on Git, but 2018 I have the stars, but I don't know where I have the code. The only hope is PyCharm. If it can find it in a project, that is. Oh, hey, 2017, did I start that? Huh, I guess I did do a few days. But that's not what we're looking for here. Yeah, doesn't seem to be able to find it. We have 2019 and 2017, but I don't know where. 24 days of code? Was that it? Hey, 2018, nice, we found it. I should probably push these. Just, oh, it's wonderful. Creative, just really don't think about it. Day 22 and 23. Yeah, see, I used Network X here. Yeah, go away. Like, I don't know what these numbers are, but I'm sure there's a reason for that. Yeah, here you go. Use a diagram, and then you construct and you add edges between the neighbors. If you want, you know, I'll commit this. There's no reason not to. So I could do that later. And then 23. Wait, did I not do 23? Where's my 23? Because I have the star. Where is 23? Named something else? 23. Why is it 42? Day 4. Oh, 4, 2. Stupid. Anyway, I don't think I'd have it here. Sort of broken. Nice. Wait, 25? There's no 25 days. Wait, no, there's 0 to 25. Never mind. Just ignore me, please. Don't know where 23 is, but goddamn, like, so close. Was this the... Oh, yeah, this was the attacking one. God, I remember that. I remember this. What a mess. 2018-24. Do I have the input? I don't seem to have the input text here. It might be here, actually, 24. This was a little bit of a mess. This was a day, all right. I remember that being a mess. Lost in the naming, yeah. Anyway, anything else interesting here? I don't think so. I think I'm just gonna go to sleep. Today was not a great day. I've done way fewer work than I need to. Wait, you know, I know why I managed to be able to do today later. I'm finally drinking alcohol. In fact, it is vodka. Salmiakki vodka. That proved to be the solution. AOC in less than 7 hours. Not for me. You know you don't have to get up that early, right? Vodka's vomit here. It's Finnish vodka. That makes it better. I prefer my vodka to come from Western Russia instead of the East. Wait, what? When you ask for non-existent keys in default dicks, Python will try to add them. God. But Aftish, you're Russian. How can you not drink vodka? Hey, look, this guy is called Haskell, and it's in C++ instead of Haskell. That's kind of sad. Yeah. Goddamn dialogue. Nothing very interesting here, but this was just as Amthish said. Wow, first part very soon of part 2. Yikes. Anyway, as Amthish was right, it's a ton of the same thing, really. Wait. Custom OS? What? Hash? Wait, this guy made his own hashing? Why would you make your own hash? You know, this seems slightly excessive. I didn't know you could be more verbose than I did. And I wrote extremely verbose. He doesn't have the libs. Ah, okay. Yeah, well, the thing is, I prefer to own the libs. All of them, so I work on Windows. A perfect setup just for Hamster. I'm sorry, is this your actual background for Visual Studio? Aftish, what's wrong with you? I am shaming you live on stream. It's your actual desktop. Slightly better. I don't even know what my desktop is right now. It's a ton of crap, that's what it is. I really should clean this up, but I never look at it, so... What's wrong with a bit of transparency? I'm not a very transparent man, that's why. God, I hate golf so much. The thing is, I never do StimRs. Like, I kind of just like ignore the checkboxes that say add icon to desktop because I never look at it. Anyway, that's gonna be it mostly for today. I'm done. I don't think there's anything else here. Who else finished this? Nix, Dennis, me, Stimar, Hamster, Fusion, Marvin, Afdish, everyone did. I was for the slowest. Why am I not here? Podium per day. It should show everyone here, but why am I not there? That's weird. Oh well, you see the timing. For once, I'm actually the slowest. Where I usually like kind of in here in the middle of the pack. Anyway, star-wise, it does. The score is not relevant at all. Because like if I just solve tomorrow faster than Stimar, I'm first. I'm like I am fifth again. Woo. Just decided to try transparency. You know what? With like 3 to 5%, it actually looks cool when you watch Nitro in the background, but also code. That must be very confusing when I'm actually like actually coding, because you see like two kinds of code behind. But I guess the transparency is so low, it doesn't really matter. Just not sure why this is not showing up here. I actually have more detailed graphs. This kind of just shows where people are. So you can see Nick's, sorry, Aftershare on top every day. I got overtaken by Marvin there. Or actual games, not code. Oh, yeah. That actually kind of neat. Because then you can listen and still get an idea of what's going on if you have a single monitor. Anyway, bit unsure why it's not showing me here. Also, why is Baz? Oh, Baz on the bottom because day one was worth no points. I think I've got everyone's Git as well. Oh, Goose actually did 2 days. Can I remove him from the list of shame? Does he have a repo yet, though? That's the important thing. He doesn't. What a guy. Actually. Oh, there it is. Never mind, it is there. Give me a second. What is it? C#? No, Rust. Just like edits. Just like Nick's. He had it for 5 days. There we go. Yeah, I don't. There we go. No, it's a bit. No, it's there we go. There we go. That's correct. I think a lot of people. Oh, yeah, he literally posted. What was that tune? Oh God, it doesn't have the individual track lists here. I can send you the link. It's called Pokey and Chill. At around 40 minutes or so. It doesn't have indexing into I guess it's an album on Spotify as well, which you could probably use to look up what exactly it is. Oh, there it is. I think it's called Ending Theme. Anyway, go ahead. Blah 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 blah. Yeah, it's Pokemon tunes. Couldn't you recognize that? It's not that difficult. Anyway, man, look at these people on day 5 being beaten by Owen. Now that is sad. What a bunch of losers being beaten by Owen. Just ignore the fact that I'm even lower than that. I guess it might only show you the top 7, but no, I'm 6 here. Oh well, no matter. Being beaten by Owen. Well, I guess he is an Aussie. He is down under, so he could probably do this in the evening. What was day 4 again? It's been pretty simple then. It shows people with medals. Yes, it does. I know. Oh, the parsing of the passwords. Just valid. You could do this literally fairly simple. Oh yeah, you're correct. No, you're right. It shows people with any medals. And of course I don't have any because I've been too slow. Because fuck waking up at 6 in the morning. I don't want to do that. No, it makes sense though. Because like, what time does Stimmer? Like, who's second most of the days? Like, well, Marvin wakes up at like 6 every day. Yeah, 4 minutes to complete for Marvin. What a guy. Hey, look, it was Marvin Day. Sorry, yeah, that's an hour to do Star 2. Today took me about 40 minutes. Probably one is done for me. Yeah, I just finished part 2 a while ago. It's like half an hour ago. Do you want to see the code or not? My defense was on train. Look, after I did last year on a train as well. I know how painful it is. Ergo, really painful. It's awful to do it on the phone. Although, are we doing it on a laptop or not? It just shows scores. So green is me. Like what there? Yeah. Day 2 is not significantly difficult depending on how you parsed it, but if you were not an idiot, you don't need to do much. For me, if you want to... The freaking driver kept the train doors open all the time so they could put my coat on and all. What? Goddamn Russia, man. Like, part B was very simple. Fairly simple for me. Just recursive search that was slightly modified. Anyway, I'm gonna end the stream here. I'm tired and I need to go to bed. It's -10. That sounds nice and warm. I don't see the issue there. Anyway, see you guys tomorrow again. With more Advent of Code. Let's hope it's not as... Today wasn't bad. I was being bad. Let's hope tomorrow I can be more competent. See you then.